Morning everyone. Today I'm going to present a topic from analysis of algorithm which focus on dynamic programming and greedy techniques. Topic is dynamic programming for binomial coefficient. This concept is very important because it helps us solve complex mathematical and algorithm problem efficiently. Throughout this, I will explain what a binomial coefficient is, the problem with the traditional methods, and how dynamic programming provides an efficient solution. So, introduction. Dynamic programming is a powerful problem-solving technique used in computer science. It works by breaking a large problem into smaller sub-problems, solving each sub-problem once, and storing the result. Instead of recomputing the same values again and again, we reuse previously calculated result. This saves both time and effort. In today's section, we will use this techniques to compute binomial coefficient efficiently. What is a binomial coefficient? A binomial coefficient is represented as C of n, k or n choose k. It means the number of ways to choose k element from n elements without considering order. For example, if we have 5 items and we want to choose 2, the number of ways is written as C of 5, 2. Binomial coefficients are widely used in probability, combinatorics, algebra, and in Pascal triangle. They form the foundation for many mathematical and algorithmic problems. Mathematical formula. The binomial coefficient can be calculated using the factorial formula. C of n, k equal to n divided by k of n minus k. Although this formula is simple, it becomes inefficient for large values because factorial calculation are expensive. It involves repeated computation. So this method is not suitable for large input in programming. Recursive definition. Instead of using factorial, we can define binomial coefficient recursively. C of n, k equal to C of n minus 1, k minus 1 plus C of n minus 1, k. This means to compute C of n, k, we break it into smaller sub-problems. There are also base cases C of n, 0 equal to 1 and C of n, n equal to 1. This recursive relation is the basis for dynamic programming. So problem with pure recursion. Although recursion is easy to understand, it has major drawbacks. Repeated calculation, high time complexity, inefficiency. Repeated calculations, the same value are computed again and again. High time complexity is it takes exponential time, approximately O of 2 power n. Inefficiency, for large inputs, it becomes very slow. So, recursion alone is not practical for solving this problem efficiently. Dynamic programming solution. Dynamic programming solves this problem efficiently by storing result, reusing values, and solving once. Storing result, we store computed values in a table. Reusing values, instead of recomputing, we reuse stored values. Solving once, each sub-problem is solved only once. This avoids redundancy and improve performance significantly. So algorithm implementation. Now let's see the step-by-step algorithm. Create a table and initialize base cases. Fill the table, return result. Create a table, create a 2D array C of n plus 1, k plus 1. Initialize base cases, set C of I 0 equal to 1, C of I equal to 1. Fill the table. Use the formula C of I comma j equal to C of I minus 1 comma j minus 1 plus C of I minus 1 comma j. Return result. The final answer is stored in C of n k. This method ensures efficient computation. Example, let's take an example C of 5, 2. First, initialize the base cases, then fill the table row by row. Each value is computed using previously stored values. Finally, we get C of 5, 2 equal to 10. This shows how dynamic programming build the solution step by step. Advantages of dynamic programming. Dynamic programming offers several advantages. Reduced time complexity from exponential big O of 2 power n to polynomial O of n into k. No redundancy. Each subproblem is solved once. Scalability. Works efficiently for large inputs. Structured approach. Easy to understand and implement. So key takeaways. Dynamic programming improve efficiency by storing result. Binomial coefficient are widely used in many fields. This method is essential for solving complex computational problems. Understanding this concept help in designing optimized algorithm. This is the mind map for binomial coefficient. Thank you.